All right. Okay. Well, happy Friday, and I guess happy Lunar New Year also for those who celebrate. Let's see. Today, so I already talked about the midterm, so that's there. I've also posted homework four. Homework four. Let me say a couple things about it. It's going to be an object-oriented programming assignment. You will code up basically the instructions, like board movement in the game Monopoly. So there's, classic board game Monopoly, and there's different rules about how the pieces move around the board. It's the board is basically kind of a loop. It's a square, but it just goes around in a loop, and players go around and around, kind of in a circle around the board. But there's a few places, if you land on it, you get sent to jail or whatever. If you land on a certain card, certain space, you draw a card, and if that card might move you to somewhere else on the board, things like that. So I wanted. So the assignment is for you to code up where you will go and move around on the board. You're going to be required to use R6 and do some object-oriented programming in that way. When you read through the instructions, it feels like a lot, okay? The instruction file is really big, and it feels like a lot, but I've tried to put in the instructions like how to think about it, how to break it down, and whatnot, okay? Again, the approach that I want you guys to have when doing the homework is to view the homework as an opportunity to practice and learn. The goal of these assignments is to make it, challenging enough for you to kind of stretch you, not overwhelm you, but also, to help you grow and improve in your coding abilities. I really want to encourage you to avoid the temptation to look for solutions or copy someone else's code and things like that. Ask questions on CampusWire if you get stuck or things happen. That's fine, but yeah, I do want you to kind of approach this like, again, just like working out or exercising at the gym or something. The point is the exercise, is that work itself. It's not that I don't have a need for Monopoly to be coded up or something like that. Okay, I don't have a need for that. But this is an opportunity for you to kind of do an exercise. So anyway, that's homework 4. That's posted and available, and you have I think a good chunk of time to get it done. So okay, let's take a look at today's lecture. I wanted to cover ggplot. I guess I just have, out of curiosity, how many of you have seen ggplot covered in class before? So, and what class was it covered in? Okay, so it's covered in 101A formally. Okay. And how much is covered in 101A? Pretty basic. Okay, I mean, I don't know. This might be pretty basic. You tell me whether we go more in depth or not. I mean, I only have like one full lecture on the topic. I try to break it down into kind of conceptually what ggplot is doing. Okay, a lot of this stuff that I'm using comes from this textbook, the R Graphics Cookbook, and the entire textbook is available to read for free at the site rgraphics.org. So, which is like, it's so great. The internet is that like you can read these like high quality. You can buy it $50, $40 online. You can also read the entire thing for free in your browser. So So it's a great resource. Okay, ggplot2, part of the tidyverse, created by Hadley Wickham. The GG stands for Grammar of Graphics, kind of this system by Leland Wilkinson, who kind of came up of, thought of a way, what does it mean to visualize data, right? It's because you've created data graphics before. You've created scatter plots. You've created histograms. Maybe not in my class, but certainly in other classes, box plots. And it's always kind of this very systematic thing of, or I don't know if systematic isn't the right word, just kind of this, follow these rules to kind of make your plot. And Leland Wilkinson kind of came up with this formal and structural perspective on what it means to visualize data. Okay, and so that's the grammar of graphics. I'm a big fan of ggplot, but I still use base graphics. Base graphics, you can do quite a bit with it. And ggplot requires your data to be formatted in a certain way, kind of in this tidy way where every observation has its own row. And if you can't be bothered trying to restructure your data into a form that ggplot works, sometimes base graphics has something that'll just get the job done. So I don't see ggplot in opposition to base graphics or things like that. And I'm assuming you covered some base graphics stuff in Stats 20. But anyway, the big idea of ggplot, or the grammar of graphics, is that we map properties or values of the data to visual properties of the graphic. And so, just a classic example is we're going to make a scatter plot. Scatter plot, you have an x-axis, you have a y-axis, and you put dots all over the place, right? If we assume our data is tidy, the properties of the data that we're talking about are basically the different columns, right? So we could have a column for the person's height, a column for their weight, a column for their gender, their race, ethnicity, hair color, et cetera, and we're going to map those things to visual properties. Visual properties for scatter plot would be something like where horizontally is it placed, the x position, and where is it placed vertically, the y position. But also you have other things like the color of the point, or the shape or symbol of the point, maybe the size of the point, or things like that. And if the visual aspect doesn't correspond, or if there's no correspondence between the data and the visual properties, it's not a data visualization. Okay, so here is just a very, very, very kind of simple example. We're going to just say, here's a table of 6 people. Okay, table of 6 people. I've just completely made up these numbers. I have these fictional heights, these fictional weights, genders, and hair colors of 6 imaginary people. We're going to say height is measured in inches, weight in pounds, and things like that. All right, so how would we create a graph for something like this? Okay, in ggplot, you would take, these are some of the different visual properties. You can say, I want the x position to correspond to the height variable, the y position to correspond to the weight variable. I want the color of the dot to correspond to the gender variable. I want the shape of the dot to correspond to the hair color, okay? And then we can say, I want every dot or every point to have size 10. And so this is what we have. And so what we see is, if I go back, here's this individual, 62 inches tall, 120 weight, gender female, hair color brown. And those aspects are shown here. The x position is at 62, the y position is at 120. The color of the dot is this reddish pinkish color, which corresponds to female. The shape of the dot is a square, or the shape of the point, I guess, is a square, and that corresponds to hair color. So all 4 aspects all four data aspects correspond to kind of visual aspects here. This, we'll say individual 3 with a height of 72, weight of 190, gender male, blonde hair, okay, is this individual up here, height of 72, weight, it's kind of hard to see on the projection screen. There's fine little, what do you call it, guidelines in the PDF. I don't know if you guys can see it on your thing, but of course, it's at 190. The color is this teal, which corresponds to male. The triangle corresponds to hair-colored blonde, right? So this is so those aspects appear for each of these dots here. Okay, so and the reason why is that why we even do data visualization in the first place is that it allows our brain to kind of utilize its visual processing powers, right? Which our brains and eyes are really good at spotting visual patterns, okay? And it allows us to kind of use that to think about quantities and values. So if we only look at numeric values, our brain is not as able to quickly reason about them. When we see the values represented kind of in this visual graphic, our brain is able to process this visual information and identify patterns and relationships much more quickly. All right. So, for example, right here, I think we start to immediately see, I don't know immediately, but we see this relationship that as X gets bigger, so does Y, right? We kind of see this positive correlation, like, in your other classes, you've learned this vocabulary of like, you have positive correlation, but even without that, you start to kind of see this pattern that, it goes from low down here and higher up there. And we're able to, because our eyes can see these kinds of patterns. And looking at this data, if I said, hey, is there a dot here that seems to have a much higher weight than we might expect, you would immediately say, or like, which dot seems most out of place in terms of having a positive residual for the weight? What would you say? You would probably identify this one, right? So if I said, hey, which dot has the greatest positive residual? Which ones have the kind of greatest negative residual? And you'd probably say something, either one of these 2 points right here. Okay, and that's because our visual capabilities are strong and able to kind of identify that, right? Versus if I just gave you this table and I said, hey, which individual here has the greatest positive residual? Which one has the weight that seems a little bit higher than we might expect? That's a lot harder to figure out, right? It's the exact same information if you think about it, right? These numbers are right here, the numbers are right here, but trying to say, hey, look at these numbers and say, well, first of all, is there any kind of pattern? And you might be able to figure out that there's a positive relationship, that as height goes up, weight also tends to go up. You might be able to figure that out if you have to stare at it. But then if I said, hey, which individual has like the greatest positive residual, that's like way harder to answer here, right? Because we just don't have that kind of we can reason about numbers, but there's a different aspect of our brain, different part of our brain handles visual information, and we're able to say, okay, this dot stands out, it's kind of high, this one's kind of low or something like that, which we can't do in this way. It's actually really amazing. This is completely unrelated, but it's really amazing that we can even get information out of this, and we don't even have to actually think about it, because like when you were 4 years old, you started learning your letters and your numbers, and we said, hey, when you see a squiggle in this shape, that corresponds to this number 6, and the number 6 is this mental concept of this quantity, and if you see it in this position, this actually corresponds to the tens places, so this represents like 60 now and things like that. And it's actually quite remarkable that like, oh, our brains recognize like, oh, this is 66 and things like that. But anyway, it's using a part of our brain that's all for like squiggle recognition and turning that into something, which is a different part of our brain for handling this. And so the data visualization, the whole reason why we create these data visualizations is that thinking about patterns when we look at numbers this way, it's a lot harder. Our brains can reason about numbers and stuff, but this is using a different aspect, different part of our brain. This utilizes another part of our brain which is much better at like this pattern recognition. And so when we do data visualization, what we're trying to do is we're trying to map these aspects of the data to aspects of a graphic, right? To utilize that, okay? And just as important is that when you have the graphic, the person needs to be able to go from the graphic back to the data, okay? So just as important as we need to have like these little labels and the legends and things like that. Otherwise, we might be able to recognize patterns, but without these kinds of guides, we can't recreate the data properties, right? When you made your first data visualization, maybe like in 4th grade or something like that, you had to you probably surveyed your classroom and was like, who's favorite this or that, and then you made a little graphic maybe, and then your teacher said it's really important that you put labels on your axes and things like that. I hope they said something like that. Maybe you made your first data graphic in middle school or something, but I think one of the important things was like, you got to label your axes. And it's absolutely true, because just as important to go from the data to the graphic is being able to go from the graphic back to the data, okay? So, if we look at this, and I said, I want you to recreate that table with 6 rows and the 4 columns, you could do it, right? We could look at this dot right here, and I say, all right, what is this person's height? And you'd say, okay, that person's got to be 68. What's this person's weight? And you'd say, well, the lines are missing on the projection. They're on my screen, but on the projection, and you'd say, okay, the weight is 165. This person's gender is male. This person's hair color is black. And you could go through all 6 points and identify all four columns, and you could recreate this exact table if necessary. It would be a kind of pain and tedious task, but you could do it, right? You could go directly from this scatter plot back to this table, and so that's an important aspect of data visualization, is that you have a graphic and you're able to go from the data to the graphic, and if you give somebody the graphic, they could recreate the data. If they can't recreate this data, then something is missing. Something went wrong with the data graphic. Okay, let me give you your first view quiz answer. What is today? Today's Friday, week 5. Friday. Our first answer is the letter B. B as in bear. B. Okay, so some terminology and theory, I guess, here. So the data is what we want to visualize. It consists of variables, which are stored as columns. The geomes are the geometric objects that are drawn to represent the data. Common geometric objects are bars or columns, lines, points. We have aesthetic attributes. These are the visual properties of the geometric objects, such as the X and Y position, but also, the line color or the shape of the points, things like that. We have mappings that say, hey, this data property, this column corresponds to this aesthetic. Scales control the mapping from the values in the data space to values in the aesthetic space. So values in the data space will be like, you have your min and your max, and then when you go to the visual space, you might the custom is to put the min on the left and the max on the right, or min on the bottom, max on the top. Okay, or if you're talking about a color, min, maybe you have this gradient scale where you go from white to black or something, and values in between are gray. And so, what corresponds to white? 0. What corresponds to black? 100. And 50 is like gray somewhere in between. And 10 would be like a light gray, and 90 would be a dark gray. I don't know. That's kind of the scale. A guide is kind of the opposite of the scale, in that once you have the visual thing, how is the person going to go from the visual thing back to the data space, right? So these include things like the tick marks on the axes, or a legend to correspond to help you translate these things. So when we look at this, we said, let's put a height on the x-axis, weight on the y-axis, the gender to be the color of the dot, and hair color to be the shape, and we did that. ggplot handles a lot of this stuff to kind of make our life easier, and it figures out the scales automatically. And so automatically it looked at our data and said, you know what, the smallest weight we had, I think the smallest height was 60 and the smallest weight was 120. And so the lower left corner of my graphic is going to be 59.5118, and the largest I think was 72,190. And so put the upper right graphic to be like 72.5 and 192, just so it has like a tiny bit of padding around it. It automatically chose these kind of this pinkish salmon color and teal to represent the genders. It chose circle, triangle, square to represent the hair colors. You have control over all of this, but if you don't specify things, then ggplot's going to automatically make some decisions for you. And then automatically ggplot also creates the tick marks and the legends for us on this thing. But again, you have a little bit of control over that as well. Okay, so this is what we have. We could change some of these mappings. All right, so here, so this one I have the person's gender going with the color of the dot, the person's hair color going with the shape of the dot, and so we have gender, female and male in our data. Our hair colors, black, blonde, and brown. Obviously there's we could have, additional colors for gender, additional shapes for hair color, and stuff like that. This was just 6 individuals. And so here I'm going to say, okay, what if we put hair color to the color of the dot, okay? And then we put gender on the shape of the dot. Okay, how is this going to change our aspect? All right, well, in our data, we had 3 hair colors: black hair, blonde hair, and brown hair. And so now we're going to have 3 colors represented in our graph, right? And then, our genders, we had female and male represented in our data. And so we have 2 shapes, circle and triangle. This is the exact same data as this graph, but it looks different. Okay. I think our eyes are drawn a little, notice color before they notice the shape. Okay. So one thing you might notice is that in general, in our data, as far as height goes, female tends to be have lower heights. Male tends to be on the right side, corresponding to higher heights or something like that. Okay, that information is still here if you look at the circles and you look at the triangles. But I think our eyes are just drawn a little bit more to the color, and you have to like really focus on the shape to kind of notice that kind of pattern as well, right? So. You can do it, but again, that's what we have. So eyes generally notice color before they notice shape. So if you have kind of different categorical variables that you want to visualize, we generally put the more important one, the one that we want to kind of draw emphasis to, on the color, the less important categorical variable represented by the shape. You might even debate, is it even worth having shape represented variable? Because if you have a whole bunch of dots, like that shape information, it will just kind of get lost. Okay. Okay, what would happen if I put hair, a categorical variable, on the y-axis. Can I even do that? So back here I have y-axis being weight, x-axis being height, hair color is the color of the dot, and gender to be the shape of the dot. What if I said, I want to take the hair color. Someone has brown hair, blonde hair, black hair, and I want to put that on the y-axis. Can I do that? Is that going to run into problems? And then what if I took weight? This person weighs 120 pounds. This person's 190 pounds. Can I put that on color? Is that going to work? What do you guys think? Are we going to run into errors? Are we going to have a graphic? Well, we can do it. And our ggplot does this. It says, okay, you've got 3 hair colors. So I've got 3 locations on the y-axis. If it's up here, this corresponds to people with brown hair. If it's in the middle regarding the y-axis, this corresponds to people with blonde hair. If we have someone have black hair, it's going to be on the bottom here. Okay. Weight. Okay. It goes from 120 to 190. So if somebody's weight is 120, they're going to have a really dark colored dot. If somebody's weight is like 190, okay, their dot is going to be colored brightly. And so we might be able to say, okay, this person and this person have lower weights. This person has a higher weight. It's a lot harder to distinguish like who's the heaviest and who's like rank these in order from lightest to darkest. And that's kind of tricky to do, especially on this projector. They all look like the same color. On my screen, I have a little bit more finer tuning in the different colors, but it's kind of hard. So technically this counts as mappings of the things, right? And so ggplot just kind of does its best with the mappings that we tell it to do. And so it's going to put each of the different categories, brown hair, blonde hair, black hair, on a different y position. It's going to color the dots accordingly to the numeric variables we have. And, on the surface, representing a number with a y coordinate might seem very different from representing a number with the color, okay? But at an abstract level, it's the same thing. We are taking a data value, a data property, and we are corresponding it to a visual property, right? One visual property is where is it going to get positioned vertically? Do I put it high or do I put it low? Another visual thing is like, how dark do I want to make this thing? Do I want to make it, light blue or dark blue, almost black? Do I want to make it big or small? Do I want to make whatever visual aspect you want to do? These are different things that we can map. We can map values, data values onto visual properties. Okay. Now, some aesthetics can work only with categorical variables. So like the shape of the point, whether you have a triangle, a circle, or a square or something, that's only going to work with a categorical variable. Okay. Some aesthetics work with categorical or continuous variables, such as the x position or y position, right? So y position, we can see that it goes with either, numeric values or not, but also, as we saw here, you can put a categorical variable on the y-axis, and it's just like, okay, if it's here in this y position, if it's up here, that corresponds to one category. If it's in the middle, it corresponds to another category or something like that, okay? In general, when you create things like bar plots, the x-axis will be categorical, but if you do a scatter plot, the x and y will be probably numeric. Okay, let me give you your second view quiz answer, the letter E, E as in elephant. We can kind of skip over this part, ggplot versus base graphics. All this section is just to show that like ggplot makes our life easy. We could do a similar graph in base graphics, put hair dots, have different shapes correspond to the different hair colors, the different colors correspond to genders and the height and the weight on the x and the y axis. But the code required to do that is a lot more painful, a lot more tedious to write, And I don't know if you've ever tried to position a legend and create a legend in base graphics. It's like, it's not fun. It's not fun, okay? This section is just to say, oh man, trying to do a complicated graphic in base graphics is a pain, whereas ggplot makes your life a lot easier, okay? And again, I love base graphics. I think base graphics are great, but there's a time and place for them, and then there's a time and place for ggplot. And so generally, if your thing is going to get more complicated, if you're going to try to visualize, I'd say, 3 or more variables, okay, like more than 2 variables, yeah, probably ggplot's the way to go, okay? So in ggplot, you just have to think about how you want to map your variables, all right, which you have to do when you do base graphics, but you think about how you want to map your variables, and once you map your variables, ggplot really does the rest for you, which is nice. And of course, if you want to have fine control over it, you also have that option and ability. Let's try to kind of talk about how we would build a graphic from scratch, okay? And so the way we work in ggplot, okay, so here's our data set. If you just do ggplot on my data frame and you just do kind of these aesthetics, x corresponds to the height variable, y corresponds to the weight variable, and you do this, you just get a blank plot with nothing on there, okay? There's no geometric objects to represent the values in the data, so there's nothing to kind of appear, okay? ggplot does look at the height variable and the weight variable and determines kind of like, well, based on the values I see there, this is where I think I should put the min and the max, but yeah, it doesn't do anything. Okay, so it kind of specifies, the mappings that we have, and after we've given this data frame, we don't have any, again, geometric objects. So we'll do is I could say, all right, let's add some point geometric objects. And so this is going to be ggplot. We have the aesthetic mappings plus geom_point. And it says, okay, well, you had 6 rows in your data frame. And so now we get 6 points, 1 point corresponding to each row, and it's plotting the height and the weight. And these are the dots that get plotted here. Okay. One thing that you'll notice sometimes is somebody might create, so over here, how did I do this? I have ggplot plus geom_point. And the plus is kind of like a weird thing in ggplot, but you can kind of treat it like these objects where you're just adding these different things. And so that previous line could just be ggplot. I store this as object P, and then I can do P plus geom_point, and we would get this exact kind of plot here, right? We can add further kind of properties, further aesthetic mappings, and I put that inside the AES function, and I say, all right, when you plot your points, map the gender variable to the color of the point. Okay, so we're going to do aesthetic mapping between color and gender here, and that appears here. All right, so in our data, again, we had our data happened to have 2 colors or 2 genders, so we have 2 colors in our data, and so we have this and this, and there you go. There is your data. This is the points are small, but that's kind of the default point size here. There is so we have aesthetic mappings. Aesthetic mappings go from data variables to data properties. Okay. On the other hand, we have something called aesthetic settings. Okay. If you just want to change the setting, you don't put the thing inside AES. Okay, so here I could say I want all of my color, all of the dots to be blue. I want all of their sizes to be 10. Okay, and this is what the plot looks like here. When you have a setting, basically all the geometric objects, in our case, all the points, have the same setting, which means there's no information, no data information that can be gleaned by looking at this. So if I said, hey, recreate the data table from this graphic, you're only able to recreate the height variable and the weight variable. You will not be able to recreate the gender column. You won't be able to recreate the hair color column because that information is not aesthetically mapped to any of the aesthetic properties. Okay, you can't look at the size of the dot and get any information out of that. You can't look at the color of the dot and get any information out of that. Okay, unless I told you, color represents a variable, then you'd say, oh, okay, well, every single person has the same value for whatever this thing is. Okay, but here, there's no variable information corresponding to the color of the dot. So that's the difference between a setting. Settings do not go inside of AES, whereas if you want a visual property to correspond to a variable, that goes inside AES. Okay, you can change the scale. That changes how the visual attributes are determined. So we could say, all right, I want to change the X scale X continuous, and I want to change my limits from to be 60 to 100, and so now the X-axis goes from 60 to 100 here, and that changes the way our graphic looks, right? You could use a log scale. You could change. You can change these kind of visual aspects here. Okay. How do you know all of this stuff? Just use Google. You go online and you say, all right, how do I change the scale in ggplot, right? So you type ggplot, X scale and things like that, and you'll find these properties. There's a lot of good documentation on the Tidyverse website and the ggplot website. We can kind of control other aspects. So if we put gender to the color, ggplot automatically determined I'm going to use this kind of pinkish salmon color, this teal color. You can say I want different colors, and you can set scale color manual, and you can say I want the colors to be orange and forest green, and if you do that, you get orange, and these are the colors. There's different named colors. But you can also kind of use hex codes and things like that. There are different themes. The projector just really washes out the gray colors, but theme black and white makes black and white lines. And again, it's kind of lost in this projection, but on my screen you can kind of see these faint lines here. Okay. One thing to do, keep in mind, is that when you use ggplot and you produce a graphic, sometimes you have to explicitly call print on that object, especially if it's inside maybe a loop or some chunk of code. You might have to, you create the graphic object and then you have to call print on it so that the plot is produced. How many view quiz answers have I given you? Just one? Two? I've given you two? Okay. I'll go ahead and give you your third one, which will be D. D as in dog. D as in dog is our third view quiz answer. D. Okay. Sometimes our data have to be transformed or summarized before it can be mapped onto an aesthetic. So for example, when you have a histogram, you have to kind of group your data into bins before you're able to make your histogram, right? So that's kind of like this little labor thing. And so, ggplot has kind of these things for making histograms, but there might be other aspects where you have to do a little bit of statistical calculations. And so there are various stat _ something functions that will do that. Okay. I wanted to just cover a few basic geometries, and we are going to run out of time. So we're not going to get through all of these slides, but on your own time, you can kind of look at the remaining things. So again, here are the references, the documentation there. I highly recommend that you read through those. Also, again, that R Graphics Cookbook is a great resource as well. There's also this cheat sheet, which shows a bunch, not all, but a bunch of the different geometric objects that can be produced, and this has a full list of the different geometric objects that ggplot can make. But probably the most important ones are like the columns or bars, the lines, and the points. Okay, so you have geom bar, geom column. Geom bar makes the height of the bar proportional to the number of cases. So if you have like a categorical variable, it counts up how many cases you have, and it makes a bar that height. If you want the heights of the bars to represent the values in your data, you can just use something like geom column. So here's a data set. We have control group, treatment 1, treatment 2, the weights. These are the different numbers here. And so if I want this to be represented with a bar, I can use geom column. Okay. For geom column, I'm going to say we're going to put the group, whether it's control, treatment 1, treatment 2, on the x-axis. The height of the bar will be that weight column, the different numeric values, geom column. And so now I have a bar or a column that says control with this height, treatment 1 with this height, treatment 2 with that height. All right, so that's a bar graph. This is a column geometry. Here you might have different categorical variables. So we have two, this is like some kind of, I don't know, plants that they were growing or something. And you have cultivar 39 and cultivar 52. I guess you're like comparing like, okay, what if I used these seeds versus these seeds? And then they're measuring like some property on, I guess, day 16, day 20, day 21. I don't, these are not going down. So I'm not quite sure what's going on here. All right. These are the weight values, their standard deviations and stuff like that. And so we might want to say, okay, I want along the x-axis, the date, all right? So we have 3 positions on the x-axis, a D16, a D20, and a D21. The height will be weight. That's going to be, the y value is going to be the weight, all right? And then the fill color, what color am I making the thing, is going to be the cultivar. And we're going to do position dodge. And what that's going to do is that's going to put our 2 different cultivars side by side, right? So we have cultivar 39 in red, cultivar 52 in teal, and we've got D16, D20, D21, and so on and so forth. And this is what that looks like, okay? And, you could change, I want the 2 cultivars and the 2 dates and swap that. So this is just kind of like another way. This is a side by side bar plot, geom column. Position equals dodge puts them side by side. If you don't have that, then they get stacked on top of each other, which could be a desirable chart that you want to make as well. All right, so you play around with it, see what kind of things happen. Here's the diamonds data set. The diamonds data set again has 53,940 rows. There's tons of information. We have different variables. Numeric, caret is numeric. The cut is a factor, ordinal factor. And so we might want to take the cut variable, and we just want to know like how many of each thing do we have, right? And so in this case, if you use geom bar, what it's going to do is it's going to go through the data set, and it's going to basically tally these up. It's going to create a frequency table of how many times ideal shows up, how many times premium shows up, and then after it figures out the count of each of those categories, then it creates bars, with their heights according to that. So geom bar would be used for kind of categorical variable where you need to count up how many times each category appears. Okay. Just more examples here. We can take. This was some data coming from the census. I think like it was like an old census, like, and we were asking like how much did the population change? And so Nevada is like one of the fastest growing states and things like that in terms of its population, right? They went from, now Las Vegas is going to get like multiple professional sports teams and stuff, right? So they had no teams, and then they got a hockey team, then they got a football team, and they're probably going to get a baseball team, and maybe whatever. Anyway, so this is mapping the change here, and so you can take different variables. We could say the regions, the south or the west. We could map that to the color. You can also rearrange the things. Oh, so here. X is the abbreviation, Y is the change, and fill is the region. Here to kind of emphasize this, you can take the same variable like change and map it to multiple aspects, okay? And multiple visual aspects, and this kind of double emphasizes it. If you reorder based on one of the variables, so here we've reordered on change, this really kind of draws emphasis to going from left to right. It goes from the least to the greatest amount of change, and then the coloring also just further emphasizes. And the color actually kind of also draws extra attention to the fact that this one is so much taller than everything else, right? There's kind of a gradual change in color from here to here, and then there's a huge jump over here as well, okay? Again, you can do manuals colors. I think these are the official UCLA colors for gold and blue and things like that, blue and gold. Other things you can change the colors onto a gradient, and so this goes from red to blue, and we see it goes from red to kind of purplish, and then there's a huge jump going from this magenta-ish to this blue color here. But you can do low to high is blue or something like that. Okay. Okay. More things. Again, we're out of time, but for line plots are kind of like dot plots, but they're connected with lines, and you can have different colored lines. If you're going to deal with a black and white kind of printout, you can change, rather than the color of the line, you can have the style of the line. Whether is it a dotted line, a solid line, stuff like that. Okay. Scatter plots, you've got the different point places, you got different shape. That's not us. Shapes, the different sizes, things like that. Okay. All right. Again, out of time. There's a few slides that you should check out on kind of you might have multiple data frames and you need to kind of combine them, and these are some of the examples on how to do that. Okay. We will end here. Have a great weekend, and we will see you Monday.